Welcome to the Explainer. Today, we're diving into the fundamentals of motion, and we're going to break down the basic rules that govern, well, absolutely everything around us.
So, what do cars, birds, and planets all have in common? It kind of sounds like the setup to a joke, right? But the answer actually points to this constant, unavoidable reality in our everyday lives. From the exact moment you wake up to the second you fall asleep, you're experiencing it. You really can't escape it. Even when you think you're sitting perfectly still, this phenomenon is happening all around you, and honestly, even to you. Figuring out the answer to this question is literally the key to unlocking how the physical universe works.
To set the stage for us, our source material kicks things off with a super simple, friendly greeting. Hello, everyone. Welcome to our science class. And you know what? Consider this your official welcome, too. We're going to strip away all the usual confusion, put on our science hats, and look at our everyday environment through a completely new, highly structured lens. And the main focus of that lens is movement. Just think about how movement scales in this perfect micro to macro arc. We start with the completely everyday stuff, like cars moving on roads. We look up, we see birds flying in the sky. We look right at ourselves, right? Humans walking from one place to another, and then we zoom all the way out into the cosmos and see planets revolving around the sun. It's not just a random list of facts. The exact same physical reality that applies to your morning commute applies to the rotation of our entire solar system.
Okay, so how do we actually make sense of all this? We see movement constantly, sure, but without a solid framework, it's really just a chaotic blur of activity. The unifying concept here is motion. This is the precise vocabulary physics uses to decode all that chaos. It's what allows us to categorize and actually measure movement. So whether it's a bird, a car, you, or the planet Earth itself, motion is simply the act of an object changing its position over time. By mastering this one concept, we master the understanding of how things actually navigate through space.
Now, to truly understand motion, we have to separate concepts that might sound identical but are actually completely different. Let's start with distance versus displacement. In everyday conversation, you'd probably use these words interchangeably, right? But physics demands precision. Distance is the total meandering path you traveled. Think about wandering through a grocery store, going up and down literally every single aisle. Displacement, on the other hand, is your direct shortcut. It measures exactly how far out of place you are from where you started, in a perfectly straight line, from point A to point B. One cares about the long, winding journey, and the other only cares about the absolute shortest route from start to finish. All right, once we understand how far things travel, we naturally need to know how fast they're doing it. And that brings us to speed versus velocity. Again, totally distinct concepts. Speed is knowing your car is going 60 miles per hour, which is great, but it doesn't actually tell you where you're going to end up. Velocity is knowing you're going 60 miles per hour north. It adds direction to the mix. If you're trying to reach a specific destination, speed just isn't enough. You absolutely need velocity. You can't truly analyze the motion of a migrating bird or an orbiting planet until you know not just how fast it's moving, but exactly where it's headed.
Which brings us right to acceleration. Because in the real world, things rarely just move at one constant speed or in one single direction forever. They start, they stop, they speed up, they slow down, they turn. Acceleration is simply the concept that captures that change. Stepping on the gas pedal, that's acceleration. Slamming the brakes, that's negative acceleration or deceleration. Even taking a sharp turn at the exact same speed is technically acceleration because your direction, and therefore your overall velocity, is changing.
So, how does this actually play out in our daily environment? Well, we categorize this into uniform motion versus non-uniform motion. Uniform motion is when things move perfectly consistently. Think of a high-speed train traveling at a super steady, unchanging speed along a straight, flat track. But let's be honest, reality is rarely that neat, is it? Non-uniform motion is when things move inconsistently. It's a car stuck navigating stop-and-go traffic, or a person weaving through a really crowded street. By sorting motion into these two buckets, we can take the messy, unpredictable movement of everyday life and turn it into something we can actually reliably study.
Once we've nailed down those underlying concepts, we need the right tools to analyze them. And for advanced motion analysis, this comes down to equations of motion and graphs of motion. So why do these matter? Well, equations are basically the mathematical language that lets us calculate the exact futures and pasts of moving objects. And graphs? They're the visual map. They allow us to literally draw a picture of speed, velocity, and acceleration over time. Together, the math and the visuals form this ultimate toolkit to predict exactly how and where any object is going to move.
Our source material actually sets a very clear goal for its students, promising By the end of this video, you will fully understand the chapter in a very easy way. And that promise reflects exactly what we're aiming for with this explainer too. While equations and graphs might sound a little intimidating at first, the entire journey, from the basic difference between distance and displacement all the way up to advanced mechanics, is built on simple, highly logical building blocks. You now have the foundational tools you need to look at movement with absolute clarity.
So, are you ready to understand the movement of the universe? We've seen how it all scales up. We know that by learning fundamental concepts like velocity and acceleration, we aren't just, memorizing vocabulary for a test. We're actually learning the underlying code of reality. You now know the mechanics behind how a human takes a single step and the precise rules that keep a massive planet in its orbit around the sun. The concepts are set, and the path from the micro to the macro is perfectly clear. The universe is in constant motion, and now you hold the key to understanding it.